Hey everybody, it's been a while since I've done one of these videos, but I'm back and we're going to talk about unit testing this time. In this presentation, I'm going to talk about why and how we can write tests for our application to make sure it is behaving correctly at a very granular level. And we're also going to play with a couple of popular frameworks and see how they can help us achieve our goal. And like I always do, we're going to jump into Visual Studio and walk us through the demo from soup to nuts so that anyone starting from absolutely nothing can follow along. So first off, to get started, we want to ask ourselves, why do we write these unit tests? And I think the real nature of unit testing is to find bugs early, but there are several other uses for them. One of the more contemporary reasons that we write unit tests is pretty obvious. We want to exercise some of our code without actually running the application. Sometimes testing the code within a running application can be a bit complicated or annoying, and we really just want to check an algorithm, for instance. Sometimes we write tests that are very specific and not well structured because we have no intention of keeping that code around, and we're just going to throw it away as soon as we verify whatever we're working on actually works. Another benefit, depending on how your project is structured, is that you can actually show somewhat definitively that the business requirements are being met. Doing this effectively can kind of be tricky depending on the area of the project that you're trying to do this with. For instance, if it's just a library, then coded unit tests are perfect. If it's a web API, then you might have to involve an API testing framework, which starts to get more into the automated functional testing sort of paradigm. And of course, if you have a UI, coded UI tests will also be needed. But in the end, these are all just tests. But the simplest way that I've been able to look at this is really that we just want to show that our code that we wrote is behaving the way that we intended it to behave. And being able to say definitively that it is can give us a much stronger confidence in our releases. So what is a unit? In the context of unit testing, a unit is actually just the smallest testable part of an application. And now that doesn't mean the single tiniest piece of your application. What we actually mean is that if we were to look at our application like a machine with many moving parts, all of which perform a very specific function, each of those functional parts would actually be considered a unit. So a unit isn't a component. We don't want to think of our account management subsystem as a unit, for instance. We want to go a bit deeper than that. So as an example, inside of a class, we have many methods. Each one of those methods could be considered a unit. However, in my opinion, that method could actually have several units inside of itself, but we'll get more into that later in the presentation. So for this presentation, we're going to be addressing a very simple problem using a couple of principles and techniques and design patterns. The most prominent of these will be solid design principles and dependency injection. So it wouldn't be a bad idea for you to pause this presentation and do some light studying on these topics before continuing if you're not already familiar with them. So immediately, for our example, we're going to be taking a look at a class that contains a single method that will return whether or not a user that resides inside of our user store is actually old enough to drink alcohol. This is going to involve us retrieving the user from the store and then analyzing their age. So we're going to take a look at a couple different versions of the same class and logic and talk about what needs to be done in order to isolate our logic and test it. Okay, so we're back here in Visual Studio, and I just went ahead and took some time to sort of stub up some of these classes that we're going to be looking at, and then in a bit we're actually going to spin up a test project and do some testing with it. So I didn't want to make you sit through all that. These are just examples anyway, but let's take a look at them. So here, sample class 1A. This is the example that we were talking about sort of in the intro. And what it is here is we have two methods in this class. We have the one that we were talking about. This is the one that we really care about, and that's the method that returns whether or not the user is old enough to drink alcohol. So outside of this class, we would just simply instantiate an instance of this class, and then we would call this method with the ID. It would go off, assumedly it would go off to a database, find the user, and then tell us yes or no whether or not the user is old enough to drink. So in this particular implementation, and it's pretty crude, but this should get the point across. We have our actual data access logic in here. So we have our little ADO connection where we say, hey, take this ID, open up a connection to the database, run this text command using this parameter, open it up, run the reader, do all this blah, 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 pull out this field, new up a new instance of the user, and then send it back to the client, which is right over here. And then we'll just look at the age and say, hey, if it's greater than or equal to 21, then we're going to return true. Otherwise, we're going to return false. So I think a lot of us have seen code like this, and rather than pick it apart and say whether or not it's right or wrong, we're just going to take a look at it from a unit testing perspective. As you can see my note up here, I don't know if you can read that. The problem with this class is, in terms of unit testing, is in order to test this class, since this is a private method here, outside of this class, it's just we can only see this. So if we wanted to test it, we would basically new up an instance of this, hand it off an ID, and then go get it. It would take care of it. But this particular implementation actually does talk to the database, which means anytime we run a test against it, it's going to have to connect to the database and find the user. And if this was run on a build server, that would mean the build server would have to have access to the database, and that's not good. Or what if we decided we were going to change that database out and use, I don't know, like a NoSQL store or an in-memory store or whatever? That would mean our test, or sorry, this class would have to be updated, and we don't know if we're going to break any other tests, but you can see how that can get kind of irritating. And plus, more importantly, it's not isolating the test, because the test has a dependency on the database, and that doesn't really help us a whole lot. We want to test this method. We want to test whether or not this one unit here, this one method, is determining correctly whether or not the user is old enough. And the meat of that is actually in the second line here, where it returns whether or not the age is greater than or equal to 21. This other process that we have to go through in retrieving the user is not the unit that we're trying to test. This is just a process that we have to go through in order to get to the meat of the problem, which is whether or not this statement is correct, whether or not this expression is correct, right? So we need to be able to cut this data piece out. So what we'll do now is we'll take a look at 1B, and notice we took all our data access out. So now this particular class, it's a little bit cleaner, but it didn't really address the core problem. And the core problem was that it has to communicate with the database. And you can see here in the constructor what we did is we got rid of that method, and we abstracted that logic out to this data source called my data source. And we just, when this class instantiates, it will have an instance here, and then our original method over here will just talk to that to get the user. Okay, so this is better, but it, again, like I said, it doesn't address the core problem in that this still has a dependency on the database. So if we run this, it's still going to talk to the database, and we can't have that. So what do? Okay, well, let's just keep running with this. So we like the idea of it being this sort of dependency over here, but the problem is we're bound to it. We're bound to this here. So no matter what we do, if we instantiate this class, my data source is going to be the one that we're driving off of, and that's the one that talks to the database. So that's not good. So we'll take a look at 1C. Now, in this example, what we did is we didn't change much, but instead of newing up the instance of my data source, we turned it into a parameter. So now whoever is using this class actually has to feed it in as an argument. But again, this doesn't really solve the problem of being coupled to the database, because this particular constructor says, hey, you have to give me an instance of my data source. But we know that my data source talks to the database, and we need to remove that. We need to remove that dependency if we're going to be able to isolate our code and be able to test it, separate of the database. So what do? So let's keep abstracting. So instead of having my data source, we'll take a look at this last example. And you can see that I've abstracted it to an interface instead. So now what this has done is this has removed the implementation details from this class. Now anything that implements this interface can be used with this class, and this method over here is actually just going to call that interface and get its data back. It doesn't care where the data came from. It can come from the library. It can come from your back pocket, a database, a file. It doesn't care. It just wants to talk to this interface, and that's where we're really going to gain our isolation from. So with that being said, we're going to show you how we can leverage this interface over here in a unit test. Okay, so now that we've taken a look at the problem, and we know that we need to unit test this method in isolation, and we have successfully removed the dependency from the database back to an interface like this. We're going to go ahead and set up the project and actually write a couple unit tests, and we're going to talk about what's actually happening during these unit tests, and we'll talk about some other some principles along the way. But first of all, let's go ahead and start the new project. So I'm just going to come over here to this solution. I'm going to add a new project. And in these templates, I'm going to come over here to test. I'm going to select unit test project. And I'm going to give it a name, unit test demo.tests. These are just conventions that I follow. What I do is my test project will have the same name as the assembly that the tests are written for, and then .tests. You can do whatever works for you. This is just kind of the convention that I follow. Okay, so this was set up a little bit earlier. I'm going to make you sit through my problems here so I can fix it for you on the spot. I reckon I could just... screw it. Okay, so let's just give this a different name. We'll put a 1 on the end of it. I had a previous demo set up, so... So anyway, it creates this template with a test template here, and we're just going to delete that. Again, so we can just walk through the whole process. One of the first things we're going to have to do is we're going to add a reference to the assembly that we're testing, which is the unit test demo. Add that reference, and we're just going to create a file that's going to test the sample class. Now, again, by my own conventions, what I'm going to do is just create a class, and I'm going to name it after the class that I'm testing, which in this case is sample class 1D, but I'm going to suffix it with tests. Okay, I'm going to put these side by side just because this is how I like to work. We're going to change this to public. Okay, so now a couple of the frameworks that we want to use to be able to perform these tests, as it's in the title, is xUnit and mock. So before we get started, we're going to have to pull in those. So we're going to go to our NuGet manager, browse, just type in MOQ for mock, first hit, install it. Go. Okay, that's installed. And then the other one we're going to pick up is xUnit. Top hit, go ahead and install. Okay. One of the other disclaimers I should give, because this could change your experience while you're doing this, is I have ReSharper installed, so my test runners are going to be in my window versus having to open up the Test Explorer and run it from there. The difference is subtle. If I think of it towards the end, I'll show you the difference between the two. But just know that I'm using ReSharper, so it might look a little bit different from you, but the meat of this presentation shouldn't be missed. So anyway, we have our test class here, and the unit that we're going to test is actually this user can drink method. So in xUnit, we do simple tests by decorating it with the attribute called fact, and then we just create a void method. And again, my own convention, what I do is I usually say, I name the method the name of the method that we're testing, so user can drink, underscore the scenario. So we'll say user is of age, and then the result that we're expecting. And we'll say returns true. So by looking at this test, I know that we're testing the user can drink method. The test scenario that we're testing is when the user is actually of age, and the expected result is that it's going to return us true. Okay, so tracking right along here. Unit tests really come in, there's three major parts to a unit test, and that is the setup, the execution, and the actual test itself, the scenario, the assertion that you're making. So you'll see this pop up a lot. The words that we're looking for is arrange, act, and assert. Those are the three steps. Okay, so arrange, this is where you set up all the variables of your test. This is us putting us into a situation where we can actually run the tests with all the pieces that we need. So right off the bat, we know we're going to need an instance of the sample class, right? So we'll say, we'll just call this the class that we're actually testing, and we'll set it to a new instance of we're going to do the 1D example, right? So notice that this isn't going to work like this because we have a dependency on that iData source. So this is normally where we would insert or inject. This is the dependency injection that we're talking about. This is where we would inject that dependency so that it can talk to the data store. And again, this class doesn't care if it's a database or whatever. It just wants an implementation of this interface. So currently, we don't have one. So we need to mock one up. So you can either make one yourself, which is called faking, or we can actually mock one. And that's what we're going to do here using mock, MOQ. And I'm going to show you how that's set up. So for now, we're going to comment this out so IntelliSense doesn't bug out. And we're going to make up a mock. So we're going to call this data source. And what we're going to do is we're going to new up a new instance of mock. And this generic parameter here is you want to tell it what it is that you're trying to mock. And the parameter that you put in there has to be some sort of abstract. You can do actual concrete classes, but you're going to get mixed results depending on what you're trying to do with it, and you won't be able to change the behavior of anything. But that's okay, because in this case, what we just want is I need an instance of iData source, right? So this gives us the mock. It's already there. But what we want to do is we want to tell it how to behave. This is the part where we're actually going to tell this mock to stand in place of our database. And instead of, for instance, we would call get user, and it would go off to the database. Instead, we're going to say, hey, when a client calls the get user function, we want you to do something specifically. So if we look at the data source, there's an extension method on here. Oh, it might not be. It's an actual method on here called setup, and it takes an expression, and we'll just call it m. And then if you type m dot, you'll notice that all of a sudden the interface members of that interface that you declared right here are all of a sudden showing up in IntelliSense there, because it knows about it now because we're going to mock it up. So if we come over here and let's just go ahead and open up that data source, you can see here's the one method in that interface, and that method is here. So what we'll do is we'll do that, and notice that it expects a GUID, right? Because that's what our interface shows, a GUID. When you're setting up the mock, what goes in here really kind of doesn't matter. So what we're going to do is we're going to use one of their methods called it is any, and then it takes a type, and we're just going to say GUID. So it's kind of fluid, right? So what this is saying is, what this is saying is like, okay, so for this data source, I want you, when this, we want to use this method. And the argument that's going to go in could be any GUID. So this says the parameter is any GUID. Okay. So what that's doing internally is the mock now has a stub in there, so that it's actually going to perform that function exactly how we tell it to right now. And what I'm going to do, just drop this down to a new line for readability, is there's another method on here following the setup called returns. And returns is going to be the result of that function. So what we're doing is saying, hey, when this function is called, return whatever I specify here. So over here, if we look, this is supposed to return an instance of user. It's like, okay, well, we need an instance of user in this case. So I'm going to say user equals new user, and I set it up ahead of time. It takes an age. And for this, we're going to say the user is 23 years old. So I'm going to go ahead and put this in here and say user. So now this data source is actually configured to return this exact user when this method is called. So before I go too much further, let's talk about this for a second. What's the point of telling it exactly what user to send back? I've been asked this a few times. It's like, it's almost cheating. Of course your unit test is going to pass. Well, that's exactly what we're trying to do. The user that gets returned from the database is a whole separate topic, right? We're not worried about the user. The unit that we're actually testing is this user is of age. We want to make sure that this logic here is behaving correctly. We're actually testing this. The user that gets fed in is just something that has to be there in order for this logic to execute. So since this test is testing the scenario that the user is of age and it does return true, I need a user that is actually of age so that I can test it, right? So by telling it exactly what age this user is, I know that if this thing is behaving correctly, it should return true. Does that make sense? That's what we're testing. I'm giving you a user that is older than 21 years old. You should return true. Okay? So now that that's fed in, whenever this method on the mock is called, it's going to return this exact user, this exact instance of the user, and that's going to be what runs through our logic. So let's go ahead and uncomment this, and now that we have this data source that is required, we're going to go ahead and feed it in. And the way that you do that with mock is it's actually the mock itself dot object, and that gives you the actual setup mock here. Okay, so now that's set up. So now what we're going to do is move on to the second step, and that is to act on it. We're going to actually run the thing. So let's go ahead and do that. We're going to say is old enough to drink is equal to class dot user can drink, right? That's the method that we wanted. And oh, it needs a GUID. Okay, well the GUID doesn't really matter, so we'll just feed it something. So we'll just say GUID new GUID. There you go. And now the method has been executed. So if things have run as we had expected, the value of is old enough to drink should be true. And that brings us to our third step, which is to actually assert that exact test. So what we do is say assert dot true is old enough to drink. That's it. That's the whole test. So now let's go ahead and execute it to see if it passes. This is the part that's different for ReSharper. These little icons here. This is actually a ReSharper add-in. If you wanted to run it without ReSharper, it's been a while, but I think you just go over here to run, and then you can look at all your tests like this, and it'll run all the tests. And I didn't find these because of the reasons. I don't know. Get back to that another time. I don't want to get too distracted. But anyway, let's just go ahead and run the test from this guy here. So this popped up off screen here, and it executed the test and it's a success. Now what that means is that we set up our test to make sure that it returns true. Should the logic be correct, it did in fact return true, so we're good. And just to test this, and we'll actually write another test specifically for this, but just to make sure that it's not blowing smoke up our butt, we'll change this to 19, and we will run this test again. And then now you can see it failed, because it expected that it was going to be true, and it was actually false. Cool. So let's go ahead and move that down here. Come on, mouse. There we go. So let's turn this back to 23 and rerun the test. The user is old enough to drink. The test passed. Okay, so that's one unit. Now, here's what I was talking about a little bit earlier when I said that you can look at a method as a single unit, but in reality, there could be multiple units in there. And this is what I mean by that. If you look at this method here that we just got done testing successfully, there's two possible outcomes. It could be true or it could be false. And we know how that works. We know that if the user's age is greater than or equal to 21, it should return true. However, the other outcome is if the user is not greater than or equal to 21, it should return false. So that's, to me, that's really two units. There's two scenarios here for us to test in order to definitively say that this method is behaving the way that we intended it to, right? Because our intention was for it to accurately tell us if the user is underage or if the user is of age. So our unit test does not, it doesn't satisfy that. Our unit test here only covers the scenario when the user is old enough. So we're going to need another test. Now the test is almost exactly the same. So in this case, what I'm going to do is I'm just going to copy paste. I'm just going to grab this whole thing and then I'm going to change the name. So it's the same method, user can drink. And the scenario is actually user is not of age. And the expected result is not returns true, it's actually returns false. All these steps are pretty much exactly the same, except the user that we want to test needs to be less than 21, so we need to make sure. Let's change that to 19. All the logic is the same, it goes off, we run the method, and then we're not asserting that it's true, we're actually asserting that it's false. So not much to repeat there. Let's go ahead and run that test. Hit run, and the test passes, right? And just to make sure it's not, actually we don't even have to check to see if it's blowing smoke up our butt, right? Because it's running the same exact method with a different set of inputs. So now what we can actually say is, hey, we have this one method here, and we want to make sure that it is behaving as designed. So we can run all tests. Bang, bang, bang. We can definitively say that that method is doing exactly what we wanted it to do. Not bad. Okay, so now there's one other thing I think we can do here is we want to make sure that it's actually getting its data from the data source, right? We look at this event, it was like, well, what if we just, put some random number in there? What if I got rid of this and said var age equals 12, and we said return true. So we just changed that. Now we're cheating, right? We're not even getting the user from the database. We're just hard coding some stuff in there. Well, watch what. Let's see what happens. Let's run the tests, and oh, it failed. Well, why did it fail? Well, mostly because this thing returned true in all cases. So the one that was expecting false didn't work. But a similar scenario can happen if the user wasn't even being retrieved from the database. So we already proved that our unit tests are useful because we broke it. We changed something over here and the unit test wasn't having it. So so we have that. But we can do better. We can do something a little bit more useful here. So change that back. We'll run our unit tests again, make sure we fix the problem. And oops, did we run all of them? This one says it's broke. Run that one. And we're good. We're green across the board. Okay, so we fixed our problem. But I want to know that it's actually pulling it from the database. So let's create a test for that. So we'll state a fact. And we'll say public void. We'll say user can drink. You can put a scenario here, but this scenario, there's only one variation, so I'm not going to put it in there. I'm just going to skip it. And we're going to say calls data source. We're just going to make sure that it's actually called. And the way that we set this up, again, so we'll say range, act, assert, and we're going to set ourselves up. So we're going to set up a data source, new mock of iData source. Cool. And then we need a, do we need a user to return? I don't think we do. So let's explore that. So I'm not testing the user. I'm not testing anything about the user. I'm only testing to make sure that the data source is being called as expected. So what I'm going to do is I'm going to say, hey, data source. And I think you have to do this unless they change this, but I'm going to do it the way I know how. So we're going to do that setup, right? M for mock. And we're going to say get user because, oop, what happened there? Get user, because that's the method we're going to call. We're going to say it is any GUID, because we don't care about that. And I'm not going to set a return value because I don't care about the return value right now. That's not what we're testing. Let's see. Oh, I just want to make sure I'm going to assert the thing. We'll see what happens. So we also need our test class. So we're going to say var class that we're actually testing equals new sample class of 1D. We're going to give it our data source object. And we're going to act on it. So class blah, blah. We're going to say user can drink. We're going to give it whatever GUID because it doesn't really matter. And now we want to test to make sure the data source was actually class. And the way that you do that in mock is that we'll just do a verification. So you can say data source.verify, M for mock, get user, and then you can do the same thing here. Get any GUID, and there's a second parameter here, and it's what you're testing for. And we'll say times dot once. Now what this is going to assert is that this method was called on this data source exactly one time. Let's see what happens. So let's run the test. And it failed. And why did it fail? Object reference not set to an instance object. So I kind of already know what that is. What it's doing is the data source is coming in and it's executing the mock, right? Getting a user, so it's getting nothing because nothing's set up to return. But then it's trying to access the age property on that nothing, and that's what's throwing a null exception. So what we'll do is the same thing that we did before, and we'll say, well, give me the user, new user, and the age really doesn't matter because we're not testing that, and we'll say returns that user. So now it shouldn't be null anymore. Let's see what happens. Run the test. Bam. There we go. So it's successful. This has successfully called that data source exactly one time. So let's see if it's actually true. So let's do that whole. Let's just comment this whole thing out and just return true all the time. So now what's going to happen is it's going to return true. It shouldn't throw any exceptions or anything, but it's not actually going to call the data source, right? Because we took rid of that. So this test should fail. Run the test. Bam, it failed. Expected the mock to be called once, but it was called 0 times. Not bad. Cool. So we'll go ahead and restore this. Control KU. And then run the test again. And we're back to succeeding. Right on. Cool. So now we have a small suite of tests here that actually exercise this class. And by running the entire suite of tests, we can say that everything that we've written a test for is actually operating the way exactly how we intended it. So a couple words about this, and I'm not going to get into a demonstration with it. I'm just going to talk about this. I mentioned a little bit earlier that solid design had something to do with this. Now, what I was actually referring to is back over here where I said that this particular unit was actually 2 units, right? There's 2 different paths that it can take, the true path or the false path, light side, dark side, however you want to look at it. That's 1 unit. This is a good example because it's a nice bite-sized piece. Now here's the problem with that. There are some developers out there that like to write these big walls of code, right? So you'll have this one method that like does 50 gajillion different things, you know, goes on for hundreds of lines, and in the end it's like, okay, so the result should be magically gravy, right? But problem with that is A, it's just not good design. I urge you not to be that guy. Don't do that. But B, it makes it even harder to test. Because now instead of testing this one method to do this one thing, you've got one method that technically does 1,000 things, and that is a violation of the single responsibility principle. That is the S in solid. And basically all that really says is that if we're going to have this class, right, this is like a nice organizational unit, everything in this class should only do things that are related to this class. In fact, you might even go as far as to say that everything in this class should be here to support functionality within quote unquote this class, this instance of the class. And to stray beyond that is to basically, you'll be losing cohesion. To do more than this class should have been responsible for is poor cohesion. So you want to split that up. Now, going further into it, each method, if we keep going with that idea, each one of these methods should also be very cohesive in that each method should do one thing really well, right? It should be focused. This method does it figures out whether the user is old enough to drink. That's it. That's all it does. It doesn't update a record somewhere else. It doesn't notify somebody that you just checked it. It doesn't, do any of these things. It does one thing. It does user can drink. And this is the meat of it. Now, if we had, say, like maybe, I don't know, 5 other different steps in here in order to get that user and maybe materialize that object to something that's being usable before we run our actual logic, each one of these steps should be broken out into its own method. Each one of these steps should be broken out into its own method so that you can definitively say that each one of these methods is performing the way that you intended it to perform. And if those methods should be public, you can write a unit test for that to make sure that they're coming out correctly. So instead of writing one unit test that tests, or like X amount of unit tests that test 50,000 possible outcomes of this single method, you can write a unit test that tests one nice cohesive method and making sure that it's behaving the way that we want it to behave. That's what we want. That's really what we want. So I'm not going to get into it in this particular presentation, but there are some gotchas that you're eventually going to run into. Like for instance, if you have private methods, how do we test the private methods? And that's really preference. I would say you don't test the private methods because the private methods don't necessarily matter. What we want to test are the public methods to make sure that they are performing how we want them to perform. And any way that they get there is really up to the implementation. That's just an implementation detail. Okay. There are other complications with testing abstract classes, for instance. You can either implement them with a fake and then test them out, or you can let those tests be run through their child classes. It's really kind of up to you. I don't have any particular opinion on how you accomplish that. Personally, I'm kind of lazy, so I'll say, well, whatever child class, I'll run the test on one of those child classes, and that'll give me the test coverage that I need. And that's good enough for me. But this is also one of the benefits of if you're going to abstract down to an interface if possible. If there's no particular behavior that you want to be obeyed while executing this, then make it an interface instead. It makes really easy to mock and abstract your dependencies. Okay, so just to kind of recap on what we've been talking about here, what we did is we took a couple different we took a look at a couple different classes here that all do the same thing, but we sort of restructured them to be more testable, is what we did. That's why we went through that exercise. So we have this method. It's got data access stuff in it. It's not exactly testable in isolation because it has its dependency on the database. So then we broke it down a little bit further and we cleaned it up, but it didn't really solve the problem. So we took it down again, and now we inverted the dependency, so it's actually injected, but we still have the same problem that it has a dependency on an actual database implementation. So then we took it a step further and we abstracted it to an interface. So now the implementation doesn't matter. And then what we did is we wrote 3 tests to test 3 specific units. That is, when we get a user of age, that it returns true. If it's not of age, then it returns false. And then we went a step further and we made sure that it was actually calling the data source and that it was only calling the data source exactly one time. So we have 3 specific units here that test very specific things about this class. And by running this suite of unit tests, we can definitively say that this class is behaving properly. Now, if you were to scale that out and say you did the same thing for 1,000 classes that build up your application, you can actually go ahead and continue coding, make modifications to existing code, and then rerun the tests. And if you rerun the tests and all the tests pass, that means you didn't break anything. Everything is still behaving the way it's supposed to behave. And then you just write new tests for any new code to make sure that those particular logical paths are being exercised and behaving correctly. So if we were to add a couple more pieces of logic in between, we would make sure that we write tests that run through those, that actually makes that code work, so that we can catch any bugs that might arise from there. Okay, and then we also took a look at mock and xUnit, which we didn't really talk a lot about. xUnit is kind of invisible. These facts are actually a feature of xUnit. And I'm going to kind of go off on a tangent here. These facts are basically simple. All this says is that there's a single assertion, and if it's true, then the test pass. You can actually take this a step further and do theories. So you can actually you could run the same test multiple times with different parameters to make sure that it's working. And I'll show you what that means. So we can change this to theory, and then we will add in a parameter here called int age. And then you can add in inline data. And we'll say this is the one that it should always be true, right? So we're going to give it an age that's at least 21. So we'll give it 23, which it used to be here, but let's replace that with age. And then let's give it 3 different values. We'll say 23, we'll say 31, we'll say 65. And what this is going to do is when you execute this test, it's going to execute this one unit test 3 times with each of these variables. And since each of these variables is over 21, this test should still succeed. So if we run that, it'll run, bang, it still succeeds with all those tests, with all these different ones. So that's a good way to make sure that your math is good. And then you can do the same thing over here with ages that are underage. So anyway, thanks for sitting through that. So there are lots of other topics to dig into with regards to unit testing. For instance, we got some repeated code over here, and you should really treat your unit tests as if they were production code. So you should use the same practices. So in that case, what we do is we would probably create a method that built this setup for us each time so that we don't have to keep repeating it. Or you'll see some people do a base class that'll do like a class under tests sort of scenario. And with these mocks, you can actually use an IOC container to deliver these to you if you want to get fancy like that. But that's kind of out of scope of this presentation. I really just wanted to show you how to write these tests and why we want to write these tests, some of the different outcomes, what we gain from it, et cetera, et cetera. And really the ultimate goal here is to sort of get your feet wet and make sure that you're not afraid of them. There's a lot of different opinions on how to write a good test. This is how I write tests because this is what's worked for me, and this is what's given me the most confidence that each individual unit of code is behaving the way that I want it to behave, and that as you build up suites of these tests throughout the life of your project, you're going to be the returns on these tests are just going to be immense. So scour the internet, look at more opinions on that, look into test-driven design if that's going to be your thing. Look into other frameworks. There's an alternative to mock. There's RhinoMox that a lot of people like. The interface is a little bit more friendlier. I just prefer mock because that's what I learned first. Other test frameworks are MS Test, which actually comes with Visual Studio. It's got some problems. It's good for basic tests, but if you're doing asynchronous programming, for instance, I prefer xUnit personally. But there's also NUnit is something that you can look into. If you have any questions, please just add them to the comments. Maybe if there's enough questions on a single topic, we can address that together, and I'll make another video and we'll go over that. Ask me about different scenarios. If you have any concerns, arguments, did I say something blatantly wrong? Just let me know. Just don't rip me apart too much. But anything, I'm gonna go ahead and conclude this video. I think we covered everything that we want to cover, and thanks for your time. We'll see you again.